we have so many transmission medias? Right. Let us go ahead to the next point, which is called as switching. Right. Now, if you talk about switching, let me cover this with the help of diagram. Suppose I'm considering a scenario. I have machine A and I have machine B. Right. In between these machines, I have few more machines. Maybe here one, maybe here. This is my network. All right. Now, A wants to send a data to B, right? And I'll draw this one more time. And one more time. Okay. Now, assume this is my machine A and this is my machine B. A and B and then A and B. Suppose I'm saying A wants to send a message. I'll say this is a message. I'll draw this message. This is also called as a packet in case of networking. A wants to send message M1 and to A is the source and B is the destination. So I will say this is one packet which I wish to transmit from this location to this location. Just give Yes, I have muted. Right. Now, A wish to send a message to B. A wish to send a message to B. Here also A wish to send a message to B. Now, when I say there can be multiple paths from A to B, do you all agree? There can be there can be a path via which your A can communicate to B through this path also. The A can communicate with B through this path also. A can communicate with B through this path also, or A can communicate from this to this also. So there can be any possible combinations of A to B which are available. Rather, I will take the same diagram one more time. So I can say there can be n number of paths which are available in my network where I can transmit the data from A to B in various ways, right? So when I talk about switching, there can be multiple paths from sender to receiver. There is something called as a technique, which is called as switching technique, which selects who is the best route for the data transmission. Yes, Nilesh, we need to select the optimum path. We need to select the best path via which my data will get transmitted correctly as well as fastly from one machine to another machine. There are three categories of switching. One is circuit switching, message switching, and packet switching. When you talk about circuit switching, in that case, what happens is there is a dedicated path which is selected. Suppose A wish to send a message to B through this path. This path is free. So first, A will say, I will establish a connection with B. Then A will perform the transmission of data. Then it will terminate the connection. This is called as the concept of circuit switching. So what is circuit switching? Whenever the data is getting transmitted from source to destination, initially the circuit is established The circuit remains alive during the complete transmission of data and then it will terminate the connection. Means ये जो मेरा पैकेट है ये completely transmit होगा from this location to this location continuously. Once this packet is transmitted, after that the data will this connection is being terminated. That is called as circuit switching. Next is basically, right Nilesh, next is basically when you wish to go for message switching. So circuit switching के लिए आपका एग्जाम्पल है टेलीफोन नेटवर्क. पहले आप फोन लेते हो, you dial it and then you will just get connected. You can communicate, you can transmit your data, you can receive some data. Once the connection is over, you cut your phone. That is basically telephone. Right? Now, M1 is basically a message that A wished to send it to B, where M1 is a message, A is a source, B is the destination. I've just drawn a simple packet in front of you so that you can understand. All right. So this is about circuit switching. When you talk about packet switching, so circuit switching, it establishes a dedicated path between the sender and receiver. जितने भी messages मुझे भेजने हैं, everything will be sent through some dedicated path. They operate in a telephone networks. There are 3 phases. First, establish the connection. Second, transfer the data. Third, disconnect the circuit. That is called as circuit switching. The next is message switching. When you talk about message switching, it is basically in the form of messages. Let us understand. Suppose A wants to send one message to B. Next, A wants to send one more packet, which I'm naming it as M2. I'll say M2. Now what will happen? In this scenario, A can say, I wish to send this packet from A to B in this direction only. यहाँ से मुझे भेजना है, ये path से भेजना है. So it will send it. A says, I wish to send up this message through maybe this path. So A will select or A will say, first message, I will transmit it through this path, and second message, I will transmit it through this path. So there is no fixed path selected for any communication between A and B. This type of communication is called as message switching. There is no establishment of dedicated path. First of all, A will send a packet to this machine. This will say, no, this do not belong to me. This will say, no, this do not belong to me. This will say, no, this will not belong, it will forward. So the message switching uses the technique called as store and forward. What is stored and forward? Store and forward is basically when the data gets transmitted through various paths, there can be multiple number of hops in between. Hops means hosts in between, and they will observe what are the basically, you can say destination address. If it is matching with me, I will keep it with me. Otherwise, I will go ahead, right? That is basically called as message switching, right? Next means circuit switching में आपका telephone network is the example where आप पहले connection establish करते हो, you transmit the data, you terminate the connection. That is circuit switching. A dedicated path is there. In case of message switching, it uses store and forward. तो यहाँ पे next machine या कौन सा path available है वो मेरा network device search करता है, accordingly it will go ahead. And the third is basically packet switching. Packet switching is basically when, suppose I'm saying A wants to send a packet. A wants to send a packet, a message to B. And assume this packet is very large, right? This data is very large, right? What this A will do, it will divide this packet into two different forms or in two different, you can say, parts. Maybe I'll say this is part 1, this is part 2, where it will add one more column or one more information over here by saying that this is the message 1 ka packet number 1, this is the message 1 ka packet number 2. This is called as sequence number. This is called as sequencing. So when A will try to transmit the data, maybe A will say, I will try to transmit this first packet from this path, maybe. From this path, maybe. And A will say, I wish to transmit second packet, maybe through this path. Right? So it has selected two different paths for its communication. Maybe first packet will go from here to here, and maybe second packet will go from this direction. And now when B will receive this packet 1 and B will receive the second packet, the B will try to perform assembling of these packets. And once the assembly is done, B will understand, okay, these are the two packets that I've received. There is no fixed path, right? In case of packet switching also. Have you understood all the three categories, which is called as packet switching? Yes, absolutely correct, Atharva. Message is divided into packets. They are given a unique number. They identify at the receiving end. Unique number means a sequence number. The packets will travel across the network through the shortest path as possible. Packets will reassembled at the receiving end in a correct order. If any packet is missing, that means the data is corrupted. The packet will be sent, or the acknowledgement will be sent, and the packet will be sent one more time. That is called as packet switching. समझ में आया? Everyone. Right. Next is multiplexing. It is also store and forward. Yes, of course. Everything Samit Shah uses in the form of store and forward. The reason is, in case of store and forward, we are in Ethernet networking. मैं आपको अभी Ethernet network क्या है वो भी बताऊंगी. So Ethernet network uses the concept called as store and forward technique. Okay, Hardik, packet means you are dividing your complete message into different parts so that it can be reassembled at the end. Assembling and reassembling of packets. The reason is Ethernet network. Ethernet network. जब मैं आपको Ethernet network बताऊंगी, तब मैं आपको डिटेल में बताऊंगी कि क्यों हम किसी भी डेटा को पैकेट्स में डिवाइड करते हैं. Packets are automatically getting generated whenever you transmit the data. And how they are generated? Because the technology behind your Ethernet network works in backend. They divide your packets into equal number of size so that your data loss should not get happen. How? I will tell you. Just have patience, right? Now, when you talk about multiplexing, right? In that case, so everyone, have you understood the meaning of, you can say, what do you mean by switching technique? All right. Okay. Now, let us say multiplexing now. If I'm saying multiplexing, it means when you talk about communication channel, it is having an optional optical fiber or coaxial cable, right? Now, they can carry one signal at a time. Since we are in Ethernet network, at a time सिर्फ एक ही नेटवर्क, एक ही चैनल से एक ही टाइप ऑफ डेटा कैरी हो सकता है, right? Now, let me come to the point where I'm saying there is something called as FM. Everyone have heard about it. It is a frequency multiplexing, right? Now, have you heard about FM radio stations? Some radio stations? Everyone? Right. Up, can you please name some radio stations? 91.1, right? 92.5, something 98.3, and so on, right? Good. Ab, let us assume I'm in Pune and I am listening to 98.3. One of my friend is also listening 98.3 in Mumbai, right? Now, can you please tell me, जो यहाँ पे ब्रॉडकास्ट हो रहा है इन रीजन पुणे, सेम ब्रॉडकास्ट मुंबई में भी होता है क्या? No, it's different. But can you please tell me the frequency number for my Pune region and for my Mumbai is exactly same, right? Then how it is possible that you are able to listen to different songs at different regions? It is because it is basically the concept of frequency or FDM, frequency division multiplexing. What happens generally over here is, actually you can consider 98.3 is one complete frequency, right? This is one complete frequency. And इस particular channel की capacity बहुत ज़्यादा है. For example, you are saying my channel capacity is 100 Mbps, 50 Mbps, 25 Mbps. ये आपके channel की broadcast, ये आपकी speed हो गई. वैसे ही 98.3 ये एक bandwidth हो गई. This is my bandwidth, right? So this bandwidth is having more capacity to transmit the data. But at a time, I can transmit one data. At a time, we can transmit only one data. तो अगर मैं इतने बड़े बैंडविड्थ में से एक ही डेटा एक टाइम पे पास करती हूं, तो will my bandwidth get wasted? Everyone? Yes, it will get wasted. That is the reason they have divided this frequency, this bandwidth into number of multiple channels. आपने कभी मक्स एंड डीमक्स डिजिटल इलेक्ट्रॉनिक्स में पढ़ा रहेगा, मल्टीप्लेक्सर एंड डीमल्टीप्लेक्सर, right? So this is nothing but multiplexing. Dividing a channel into number of channels is called as multiplexing. When you are dividing frequency into multiple channels, that is called as frequency division multiplexing. And when you are dividing time for transmission of data, then that is called as time division multiplexing, right? So if I'm saying I'm in Pune region, तो मुझे सिर्फ इतना ही बैंडविड्थ दिया गया है 98.3 का. If I'm saying I'm in Mumbai region, so I have been given this much range. When you travel, suppose I'm traveling from Pune to Mumbai, right? And when I'm traveling from Pune to Mumbai, in that case, at some time of point, जब आप across लोनावाला या थोड़ा सा उसके आगे जाओगे, तो बीच में ही आपका सॉन्ग अगर चलता रहेगा, कट होके आपको मुंबई का ब्रॉडकास्टिंग सुनाई देता है. Have you ever observed whenever you travel, all of sudden your voice which was getting transmitted in Pune exactly half में ही cut होके वो मुंबई का broadcast कर देता है. It is because this band which is maintained between two regions, that is called as guard band. Have you understood? That's the reason we say a complete bandwidth is divided into number of regions, and these regions have the same frequency range, but it is divided into smaller channels. That's why it is called as multiplexing. Since I am dividing it into frequency into multiple channels, that's why it is called as frequency division multiplexing. So why do we use multiplexing? Because we do not want to waste bandwidth. That's why we go for multiplexing. So there are two categories of multiplexing, FDM, another is TDM. FDM is frequency division multiplexing, TDM is time division multiplexing. When you talk about time division multiplexing, suppose I'll say I will form a frame where I'll say I have 3 machines who wish to send the data. This is my first machine, A machine. This is my B machine. This is my C machine. I'll just give a name convention. This is A, this is B, and this is C. If I say मेरा machine A है, उसके लिए my machine A is having a you can say is allowed to pass its data only this frame. My machine B can only transmit data through this frame. My machine C can only transmit my data through this frame. So that means there is one frame which is divided based on the time given to them. Also, the frame is divided in such a way कि जब भी मेरे पास फ्रेम आएगा, अगर A को डेटा सेंड करना है, A हमेशा इसी स्लॉट में भेजेगा. अगर B को डेटा सेंड करना है, B को भी भेजना पड़ेगा इसी स्लॉट में. अगर डेटा नहीं भेजना है, that frame will go empty. This kind of category is called as synchronous TDM. The frame is fixed for each and every device who wants to send the data. Suppose A wants to send 2 times data. So 2 बार frame में जाएगा, दोनों frame में मेरा data यहाँ पे जाएगा. Suppose B says I do not want to send the data next time, तो B का यहाँ पे empty हो जाएगा. C says I wish to go for 3 type of data or 3 times I wish to send the data. So next time जब frame जाएगा तो सिर्फ C का data जाएगा, rest all will remain. Rest all will remain this. Have you understood? This is called as synchronous TDM, right? But can you observe in case of synchronous TDM, this bits और ये जो सारी fields है, ये waste जा रही है. My bandwidth is getting wastage. This is called as wastage of bandwidth. This is called as synchronous TDM. But in other scenario, suppose I have same scenario, A, B, and C wish to send the data. Instead of freezing the frame number, I will freeze a frame size. Maybe I'll say my frame size is a 4. So maybe 1, somewhere, okay, 1, maybe I'll say 3 frame size. This is the frame size, right? In case of asynchronous TDM, A says, I wish to send 2 times data. So maybe A का data इधर जाएगा, or let us say, somewhere I have not drawn it correctly. ठीक. Okay, you can understand. Suppose A says, I wish to send the data twice. So A will be sending the data over here and let us say over here. B says, I just want to send data only once. So B will send, let us say over here. C says, I wish to send the data 3 times. So C will send over here. यहाँ पे मेरा बैंडविड्थ का वेस्टेज नहीं हो रहा है, दैट इज कॉल्ड एज asynchronous TDM. When the time is divided time is given to the frames. For example, if I say you can transmit your data between 12 to 12:15, 12:15 to 12:30 is given to the B machine, 12:30 to 12:45 is given to C machine. So when I'm dividing the time, then that is called as division of time, and that is called as time division multiplexing. Have you understood what is the need of multiplexing? What is asynchronous and synchronous? To avoid a wastage of bandwidth, multiplexing lagta hai. So this is just the difference that I have kept. TDM works with digital as well as analog signals. The FDM works only with analog signals. They have very low conflict. They have very high conflict. When why high conflict? Because जब मैं आपने अगर सुना रहेगा FM में भी, when you travel, ऐसा एक लोकेशन आता है जहां पे हमें नॉइज भी सुनाई देता है, सॉन्ग भी सुनाई देता है, और कुछ तो डिस्टर्बेंस आता है. It is because of the guard band which is there available, but there is very high conflict in case of frequency division multiplexing. In TDM, time sharing takes place. In FDM, frequency sharing takes place. Here, the synchronization pulse is necessary. Here, the guard band is necessary. Here, you can say in TDM, basically they enable the synchronization. And here, they do not do any synchronization, but there is some kind of overlapping that occurs in case of frequency division multiplexing. So we have seen what is switching. We have seen what is multiplexing. Any questions so far? There is no sequence of traveling, right? Need of sequence of traveling. It is because it is not decided basically for you, or you are not able to decide which basically path we should go for. It's the network device who decides which path we should go for. Okay. Right. Any questions so far? If no, I'll proceed ahead then. Network classification. Good. All right. Now, when you talk about classification, it means हम network कैसे form कर सकते हैं. Shrikant is asking asynchronous TDM. Shrikant, in case of asynchronous TDM, I'll just go there. Right. Asynchronous TDM में just give me a now, when you talk about asynchronous, in that case, ये frame size fix है. और श्रीकांत, can you observe? ये मेरा frame number 1 है, right? This is my frame number 1. This is my frame number 2. This is my frame number 3. This is frame number 1, frame number 2, and frame number 3. This is frame 1, frame 2, and frame 3. जब भी ए को डेटा सेंड करना है, वो सिर्फ फ्रेम ए के थ्रू 1 के थ्रू ही सेंड कर सकता है. जब बी को डेटा सेंड करना है, he can send it through only frame 2. When C wants to send the data, he can send only through this. This is called as synchronous. Means I am not mixing the data. But what is the disadvantage? Disadvantage is here there is a wastage of bandwidth. जब ए को डेटा सेंड ही नहीं करना है, तो ये एम्प्टी जाता है. अगर एम्प्टी जाता है तो उसको वेस्टेज बोलते हैं. Similarly, when you talk about A, B and C over here, यहाँ पे फ्रेम का नंबर फिक्स नहीं है. एक कैसे भी डेटा भेज सकता है, बी भी कैसे भी डेटा भेज सकता है, सी भी कैसे भी डेटा भेज सकता है. फ्रेम नंबर इज नॉट allocated. That is called as asynchronous. Is it okay? Got it. All right. So we will proceed ahead to the next concept, which is called as classification. अगेन जब हम ट्रांसमिशन मीडिया में थे तो हम डिस्टेंस की बात कर रहे थे. If I want 100 meter distance, I'll go for twisted pair. If I go 1 kilometer distance, I'll go for coaxial cable. More than that, I will go for basically, you can say, fiber optics, right? Similarly, when I'm talking about network classification, in that case, how your network is to be laid out means क्या मुझे 100 मीटर रेंज चाहिए, क्या मुझे 1 किलोमीटर रेंज चाहिए, whether I have to form a network in a room, maybe in a building, maybe in a campus, maybe in a city, maybe in a country, or maybe over the planet, and so on. So for that, when I say if I wish to decide the type of network as far as geographical concern is there, geographical boundary is concerned, then I will classify by network in the form of LAN, WAN, and MAN. So what is LAN, WAN, and MAN? They are basically the types of network which decides the boundary of your network. LAN stands for local area network, WAN stands for wide area network, and MAN stands for metropolitan area network. When you talk about personal area network, मतलब आपका 1 मीटर का 1 square meter means you can say your home network is your personal area network. Local area network 10 meter, 100 meter. Metropolitan area network, campus or city. Wide area network, maybe you can talk about country and continent. Internet, you're talking about planet. So the distance is basically that you go for is 1, 10, 100 meter, 1 kilometer, 10 kilometer, and so on. There are many types of other networks, which is PAN, which is private area network or personal area network. There is something called as SAN, which is also called as storage area network and server area network. There is some, you can say LAN, MAN, WAN, PAN, SAN. ऐसे बहुत type of networks है. But they basically belong, the major two categories are LAN and WAN only. मैन भी एक्चुअली मेजर कैटेगरी में नहीं आता है बिकॉज इट इज इंटरमीडिएट, बट मेजर टू कैटेगरीज ऑफ नेटवर्क्स आर लैन एंड वैन, right? This is according to the network geography. Along with that, sometimes we say I want to make a client server communication. Sometimes you say no, I do not want client and server, I want only clients to be there and machines to be connected, I do not want any kind of server. Sometimes you say no, I want one machine as a printing who can do only printing job and do as a print server. Sometimes you say no, I just want to have a file server. Sometimes you say I just want email server. So accordingly हम मशीन के रोल के हिसाब से नेटवर्क बनाते हैं, and that is called as classification by component roles. So you can classify your network based on geographical area, you can classify your network based on component roles. That is basically called as network classification. So we will see what is a LAN. LAN is basically wired network. It can cover 100 meter range. Local interconnectivity के लिए we go for LAN. In your labs, in your colleges, in your offices, if you have a very small range that is 100 meters, we will go for LAN. Now, the question can come as, if you have to form 100 meter range network, which type of wired network you will go for? I'll repeat the question. If I want 100 meter range, then which type of network you will go for? Obviously, you will say, I'll go for LAN. Good. If the question comes, if I wish to go for 100 meter range, right, and which kind of transmission medium you should go for? You will go for twisted pair cable. Are you understanding the scenario कि transmission media क्या है और network क्या है? Right, good. So this is about local area network. जब हम local area network की बात करते हैं, तो there are 3 types via which you can form. I'll go from down. Let us say broadband system. कभी कभी आपके केबल सर्विस प्रोवाइडर जो रहते हैं वही आपको कोएक्सियल केबल देते हैं और आप नेटवर्क कनेक्ट कर सकते हो. हैव यू हर्ड अबाउट इट? Or sometimes your phone connection is also there, and that same wire you can use for your laptop for making a LAN connectivity. These two are very common, but the most commonly used is Ethernet system, either the twisted pair wire or coaxial based, and Ethernet network is used in case of your networking. So Ethernet क्या है? It's a system. What it is used for building up a wired network. तो wired network आप broadband system से भी बना सकते हो. You can make a broadband using phone line, or you can form a Ethernet network, or you can set up a wired network with the help of Ethernet systems. Right? Now, when you talk about wired network, there are two categories. One is token ring, another is Ethernet. Let us understand. If I say first, second, third, fourth, I have four machines. Machine A, machine B, machine C, and machine D. If machine A wish to send some data M1 to C, this is message M1 which A wish to send to C. The message will first go to B. B will check, am I the destination? No, right? Here, the message will get transmitted to C. In this scenario, what happens in case of token ring? Token ring may, there is, let us say, one empty box, which is also called as empty token. This empty token is taken to A first. A wish to send a message. A will put that message into that box. This token will get transmitted from A to B. Now B will observe, am I the destination? No. It will just check the destination address. It will forward it. This token will be transmitted to C. Now C will observe, am I the destination? Yes. C will take it out, and that is how it will process. Again, the ring fashion is formed between the machines. That's why it is called as token ring. Again, this empty token will get transmitted from C to D. If D says, I don't want to transmit data, this will go to A. This will go to B. This will again come to, let us say, C. Now C says, I wish to send an acknowledgement. So C will send an acknowledgement. To whom? From C to A. So this message will be put again into the box, right? If I'm putting this message into the box, this token will again go into the ring fashion to D. D will say, no, I'm not the destination. It will go to A. A will observe, yes, this packet belongs to me. I will put it, and this is how it works. This concept is called as token ring, where the ring type of network is formed between your machines using some cabling media. But nowadays, we do not use token ring, because maximum speed your token ring can go for 4 Mbps to maximum 16 Mbps. Also, it is very costly because it is developed by IBM, and which is paid, you can say, copywritten. So always the licensed copies are hard, you can say, costlier than the free one. That's why we do not go for token ring. Have you understood the functionality? Right. Next is Ethernet. When you talk about Ethernet, it is worldwide used nowadays. If you want to go for 10 Mbps, it's Ethernet. 100 Mbps, fast Ethernet. 1 Gbps, gigabit Ethernet, and so on. So this is called as Ethernet network. Now, when you talk about Ethernet network, let me explain. This is the token ring that I have explained, where the ring type of network is formed, and the token passes from one machine to another machine. Every machine uses a listen mode and transmit mode. This is called as token ring. The Ethernet transmit speed is 10 Mbps up to 100 Mbps or more. It was freely available. It was developed by Xerox company. Ethernet is a dominant cabling, and Ethernet is basically the most commonly used. Coming to your point of Ethernet, I'll explain few concepts together. Initially, I have started with NIC card, right? NIC stands for Network Interface Card. NIC card पे एक address printed रहता है, which is called as unique address. Every machine is having its own unique address. This unique address is called as NIC card address, or this address is also called as MAC address. This address is also called as physical address, or this address is also called as NIC card address, or this address is also called as Ethernet address. These are the different names of NIC card address, right? Now, every NIC card जो भी आपके मशीन पे है, हर एक NIC कार्ड को बहुत सारे एड्रेस, बहुत सारे I'm sorry, it is having many names, but they are uniquely, universally. Now, why we use NIC card? Because NIC card के वजह से ही हम नेटवर्क में कनेक्ट होते हैं, right? NIC is basically network interface card which is on your motherboard. तो आप जब आप लैन केबल कनेक्ट करते हो ग्रे कलर का ट्विस्टेड पेयर, तो आप एक्चुअली लैन केबल एक पोर्ट में कनेक्ट करते हो, कनेक्टर रहता है, yes or नो? तो वो किसके पोर्ट में आप कनेक्ट करते हो? वो पोर्ट का जो देयर आर टू ऑप्शंस, राइट? कनेक्टर में देयर इज यू हैव अ ट्विस्टेड पेयर केबल, राइट? वो इथरनेट पोर्ट में कनेक्ट करते हो, तो उसको हम, वो जो पोर्ट है वो कहाँ पे है? एनआईसी कार्ड का पोर्ट रहता है वो। आया समझ में? मतलब आपके मदरबोर्ड में एनआईसी कार्ड माउंटेड है, एनआईसी कार्ड में कनेक्टर का स्लॉट है जहां पे आप ट्विस्टेड पेयर केबल कनेक्ट करते हो। हैव यू अंडरस्टूड एवरीवन? देयर इज वन मेल कनेक्टर, देयर इज वन फीमेल कनेक्टर। तो जो ट्विस्टेड पेयर में कनेक्टेड है वो वन टाइप ऑफ कनेक्टर है, एंड एनआईसी कार्ड का कनेक्टर, दे बोथ गेट कनेक्टेड, दैट्स व्हाई यू आर कनेक्टेड ओवर द नेटवर्क। आर यू गेटिंग? सो दिस इज कॉल्ड एज एनआईसी कार्ड, राइट? तो जो NIC कार्ड पे एड्रेस होता है वो यूनिक प्रिंटेड रहता है, and that NIC card is having something called as address which is called as Ethernet address, right? Now yes, RJ45 connector, absolutely correct Tushar. Ethernet address का size रहता है 48 bits. This is fixed. This is fixed. 48 bits means 6 bytes. हर NIC कार्ड पे जो भी एड्रेस प्रिंटेड रहता है वो 6 बाइट्स में रहता है। इट इज लाइक फर्स्ट बाइट कोलोन, सेकेंड बाइट कोलोन, थर्ड बाइट कोलोन, फोर्थ बाइट कोलोन, फिफ्थ बाइट कोलोन एंड सिक्स्थ बाइट। दैट इज बेसिकली when you talk about MAC address, it is basically in 6 octets. Are you getting up to this point? 6 octets of 8-bit each, correct? Now, suppose I am, now very important, suppose I am the Dell manufacturer, right? Someone is Apple manufacturer. Someone is maybe Toshiba or HP. Assume. अब जब डेल का मेरा लैपटॉप बनेगा तो उसमें एनआईसी कार्ड रहेगा, मे बी फर्स्ट लैपटॉप बना उसका एनआईसी कार्ड, सेकेंड लैपटॉप बना, उसका एनआईसी कार्ड। सिमिलरली एप्पल का भी बनेगा, तो फर्स्ट बनेगा तो उसको एनआईसी कार्ड रहेगा, सेकेंड को भी एनआईसी कार्ड रहेगा, एंड सो ऑन एंड सो फोर्थ. When I'm saying Dell is saying I want to give numbers from 1, 2, 3, 4. Apple is also saying I will give my NIC card same numbers. Will it be a conflict between these two? Will it keep a universally uniqueness into it? Obviously no. So that is the reason there are some organizations who allocates first 3 octets reserved for the organization or the company. For example, if I'm using a Dell laptop, डेल के सारे एनआईसी कार्ड्स का जो मैक एड्रेस है वो फर्स्ट 3 बाइट्स 20, 47, 47 ऐसा ही रहता है. रेस्ट 3 ऑक्टेट्स गिव्स मी द यूनिक कॉम्बिनेशन. आर यू गेटिंग द सिनेरियो एवरीवन? तो जब भी डेल कंपनी ने पहला लैपटॉप सपोज बनाया या पहला मशीन बनाया, उसको नंबर दे दिया 0. दूसरा लैपटॉप बनाया 20, 47, 47 रिजर्व रहेगा. दूसरा लैपटॉप बनाया तो उसको 1 दे दिया. So can you imagine there are 24 bits which are there, means unique combination will be 2 raised to 24. Can I say it is a very big number? तो इतने नंबर ऑफ एनआईसी कार्ड्स मैं मैन्युफैक्चर कर सकती हूं एज अ डेल मैन्युफैक्चरर, right? Have it kept a uniqueness also? Yes, it have kept a uniqueness. That is the reason when you talk about NIC card, in that case, the first 3 octets are reserved for the manufacturer. Rest 3 octets can be uniquely identified. ये मैं आपको क्यों बता रही हूं? बिकॉज एनआईसी कार्ड पे ईथरनेट एड्रेस प्रिंटेड रहता है विच इज ऑफ 6 बाइट्स, एंड हाउ इट इज यूनिकली आइडेंटिफाइड दैट यू शुड अवेयर. Have you understood what is Ethernet? This is how I have written. Ethernet is basically the net card which is having a printed address onto it, which is of 6 bytes each. First 3 bytes are reserved for the organization, right? What is NIC card? It is basically used for my computer to get connected over the network. Now, when you talk about network, as I was talking about, here I'm saying I have machine M1 or I want to pass message 1 from A to machine C. Okay, in that case, this is called as a packet. This is called as a packet, right? Now, have you ever observed, normally अगर आप फोन से नॉर्मल टेक्स्ट मैसेज की बात कर रही हूं, इफ यू सेंड अ टेक्स्ट मैसेज के कैरेक्टर्स की कैपेसिटी क्या रहती है? मे बी 160, राइट? Yes or no? Yes. Now, अगर मैं 200 कैरेक्टर्स इंसर्ट करती हूं तो मेरा टेक्स्ट मैसेज M1 और M2 में डिवाइड हो जाता है. 160 and 40 कैरेक्टर्स ऑटोमेटिकली होता है, राइट? नाउ व्हेन आई सेंड अ ईमेल, कैन आई सेंड ओनली डॉक्यूमेंट्स थ्रू ईमेल? Obviously yes. Can I send text plus document through email? Of course yes. Can I only send a text through email? Of course yes. Means can I say I am dealing with variable length of data while passing the data to the network? Obviously yes. Right? Now ये कैसे डिसाइड होगा कि मेरा वेरिएबल लेंथ है, मेरा फिक्स्ड लेंथ है, और कैसे है? इसके वजह से Ethernet network divides the packets into equal size. What is that size? Which is 1500 bytes only. That means at a time in one single packet 1500 bytes data transmit हो सकता है. Now If someone says, I wish to pass 3500 bytes my data, तो वो डिवाइड कैसे करेगा? पैकेट 1 1500 bytes, पैकेट नंबर 2 again 1500 bytes, right? And packet number 3 500 bytes. Is it nothing but 3500 bytes? Yes. समझ में आया? इसलिए आप कितने भी वेरिएबल लेंथ का डेटा बेचते हो तो वो सारा डेटा हमेशा जिस सीक्वेंस में रहता है उसी सीक्वेंस में आपको मिलता है। Have you ever observed? आपने ईमेल किया रहेगा, यहाँ आप मैसेज करते हो, ऐसे नहीं होता है कि खुद ही टेक्स्ट चेंज हो जाता है या फिर खुद ही रैंडम डेटा मिस हो जाता है। Never. The reason behind that is we are using Ethernet network. In case of Ethernet network, the packet size is reserved, which is designed. So it means that length of the each message in the Ethernet packet is maximum 1500 bytes. तो यहाँ से उसको sequence number मिलेगा at the receiving end, वो assembling and deassembling करते हैं फिर। Have you understood, everyone, the internals of MAC address and the Ethernet address, right? So Ethernet address का ये है पैकेट फॉर्मेट। जैसे मैं आपको बोलती हूँ ये मैंने पैकेट ड्रॉ किया है, मैंने छोटा ड्रॉ किया है कि जस्ट मैंने मैसेज सोर्स और डेस्टिनेशन लिखा है, बट एक्चुअली योर ईथरनेट पैकेट लुक्स लाइक दिस। This is start frame byte, SFD, which informs, yes, this is the starting of my message. Then comes destination MAC address. Destination MAC address means कहाँ पे मुझे डेटा भेजना है उसका MAC address. Then comes source MAC address. That means the generator who sends the message. That is a type. Type indicates whether I'm going for IPv4-6 protocol, IPv6 protocol, and so on. कौन से rules and कौन से standards मैं follow करती हूँ, that is maintained by the type. The data and padding is basically the important factor which basically divides your data into 1500 bytes. It means अगर पैकेट 3 में सिर्फ 500 बाइट्स है तो बाकी का डेटा क्या रहेगा? 1000 बाइट्स विल बी द पैडिंग ऑफ डेटा. Padding means maybe 000 or something like that. And finally, FCS is a sequence number which is maintained. Because if some packet gets lost, if the sequence is not proper, it will give you an error. This is called as Ethernet frame format, which is designed already. It is a protocol standard. It is the standard that we follow when we are connected over the network. समझ में आया? What do you mean by MAC address and Ethernet network, right? Similarly, when this is about LAN network, when you talk about WAN or when you talk about MAN, it is basically a distance of metropolitan city. The cost of installation and operation is little higher, but when you talk about MAN, normally cable television networks uses MAN network. अगर केबल टेलीविजन नेटवर्क का ट्रांसमिशन मीडिया पूछा तो आप बोल सकते हो कोएक्शियल केबल, बट इफ यू टॉक अबाउट केबल टेलीविजन नेटवर्क दे यूज मैन नेटवर्क, right? MAN stands for Metropolitan Area Network, where I have more than 100-meter range. When you talk about WAN, WAN stands for Wide Area Network. Actually, WAN क्या है? When you try to connect smaller networks together, then that is called as a WAN. For example, if I'm saying I have a router and there is a small network which is built at my home. That is small network. But when I'm saying I'm connected over the network, I'm connected to you, you are also connected to a smaller LAN network only, let us say. So am I connecting network to network? Then that becomes as a WAN. Are you getting the meaning of WAN? So WAN is basically when I'm trying to connect few smaller networks together, then that is called as WAN. So how that gets connected, for that we have networking devices that I will explain tomorrow. right? So have you understood what is LAN, MAN, and WAN? Good. Now, when you talk about networks, in that case, as I said, हर एक machine में, let us say this is my sender A. Let us say this is my receiver B, right? If this is machine A and this is machine B, तो can I say machine A को खुद का MAC address रहेगा, MAC of A, which is universally unique. Can I say machine B को भी उसका MAC रहेगा? I'm just writing MAC of B, which is also unique. Can I share my MAC address with other persons? Obviously no. The reason, because it is uniquely given, someone can hack it. That's the reason we do not share a MAC address. So what we do, we give a IP address to each machine, right? IP address stands for Internet Protocol Address. So this is called as physical address of my machine A. This is called as logical address of my machine A. This is also a physical address and this is also logical address. Means can I say हर एक मशीन को अब दो एड्रेसेस हो सकती है, एक मैक एक आईपी, यहाँ पे भी एक मैक एक आईपी, राइट? जब मैं नेटवर्क में बाहर जा रही हूं तो मेरा आईपी एड्रेस सबको पता है, राइट? जब मैं वापस नेटवर्क के अंदर आ रही हूं तो मेरा मैक एड्रेस पता होना चाहिए. डू यू ऑल अग्री? Right? So there should be someone who can perform IP to MAC conversion, and that is nothing but done by address resolution protocol, which is nothing but ARP. So what is ARP? ARP is a protocol which tries to convert IP address to MAC address. IP is 32-bit, वो कल बताऊंगी, and MAC is 48-bit conversion. So this is one protocol which works specifically on your IP and MAC addresses. This is ARP. So what is ARP? It's address resolution protocol which tries to find a network address of a computer in the network. It is basically used to translate 32-bit into 48-bit addresses and vice versa. Because I cannot share my MAC address, that's why I have to go for something called as some converter who can convert my logical address into physical and physical address into logical. समझ में आया what is ARP? Everyone? Good. Now, we have seen transmission medias, right? We have seen mode of transmission, simplex, duplex, simplex, or you can say two-way directions, and so on. Then we have seen transmission medias, right? Coaxial cable, fiber optics, twisted pair. Later on, we have seen the type of connectivity, maybe LAN, MAN, WAN. ये हुआ मेरे different types of network. कैसे कनेक्ट करते हैं, क्यों स्विचिंग यूज करते हैं, क्यों हम लोग मल्टीप्लेक्सिंग यूज करते हैं, वी हैव सीन दैट. बट व्हेन आई से आई विश टू कनेक्ट मशीन्स, I can connect machines in two ways. One is a point to point, another is multi-point. Means physically मैं मेरे machines को कैसे connect करूंगी so that my machines can get connected over the network. If I say single transmitter and the receiver, I'll go for point to point. If I say multi-point, it means multiple recipients of the single transmission. For example, if you send one-to-one message, it becomes point to point. But if you send a message to multiple candidates, multiple students, in that case, it is a one to multi-point, and so on. Means multiple recipients are there for single transmission. That is multi-point. Now, when you talk about topology, it refers to the way a network is laid out physically. अगर मैं बोलती हूँ मेरा मशीन ये कनेक्टेड रिंग फैशन में है, तो मैं इसको रिंग टोपोलॉजी बोलूंगी. आपने अभी ऑफिस में या कॉलेजेस में देखा रहेगा कि एक स्विच रहेगा, स्विच के थ्रू वायर्स आती है एंड देन आपके पास एक बड़ा सा केबल रहता था, वहां पे आपको ट्विस्टेड पेयर वायर्स रहती थी एंड दोस ट्विस्टेड पेयर वायर्स यू हैव कनेक्टेड एज अ लैन केबल फॉर योर लैपटॉप्स. Do you have you ever seen this kind of setup, right? So it means this kind of setup is basically done because I want how my physically network is formed. The representation of the network specifies the topology of a network. So there are three types: unicast, multicast, and broadcast. When I say unicast, it means one-to-one communication. Multicast means one to many, and broadcast is one to all. That is called as type of transmission. Now let us go ahead to the topology. Point to point means one to one. Multi-point means एक ही transmitter है, but there are multiple you can say stations. There are four topologies. One is mesh topology, star topology, bus topology, and ring topology. Look at the diagram now. In case of mesh topology, the machines are connected in one machine is connected in all the four machines. That is mesh topology. Here I need more number of wires. But the advantage is, अगर ये machine suppose down हो गया, will it affect the complete network? Will it affect the complete network? No. That is what is the advantage of mesh topology. Can I say one machine is point to point connected with another machine? Yes, point to point, one to one connected. That is called as mesh topology. In case of bus topology, which you have in your labs normally, I have one backbone cable from where there are some twisted pair wires. Those are called as drop lines via which I can get a connectivity. In case of bus topology, can I say if one machine goes down, it will not affect the whole network? Yes. But if the whole backbone cable goes down, then it will bring your network down. Can I say bus topology is also a point to point topology? ये एक point एक machine के साथ connected है. No, you can say bus topology is a multi-point, right? Because एक connecting है and multiple machines are connected on one single cable line. It's a multi-point, one to many, right? When you talk about star topology, there is a central controller. I have written hub, but right now I will not explain what is hub. We will see tomorrow. There can be a star topology, in which there is a central controlling device and multiple devices are connected with it. That is called as star topology. In case of star topology, आपको अगर याद रहेगा कि एक switch रहता है labs में, through switch your other networks are formed or they are connected with number of machines, right? Like a router also. Your router is connected with multiple machines and that is star topology. When you talk about ring topology, it is similar to your token ring, where one-to-one machine connectivity is done. In case of star topology, if one machine goes down, it will not affect the network. In case of star topology, if central controller goes down, the complete network goes down. In case of ring topology, if one machine goes down, then it will completely affect the network. So ring is also a point-to-point topology. Here, star is multi-point topology. One to many, they are connected. This is called as topology. समझ में आया, everyone? Did you all understand the meaning of topology? Right? I will share this PPT and we will see networking devices in tomorrow's class. Right? I'll be uploading the video soon and we will stop here. So we have seen basically the students are having the queries ki why we have networks, even though it is not mentioned. It is because when you talk about computer fundamentals, it comes as a computer fundamental and the networking. That is the reason we generally cover computer fundamentals, that is the basics of computers, in the first session. Second and third day is divided into computer networks subject. Now, what exactly a data communication network is and what are the things that we can go ahead with it? Let us discuss that first. So when we talk about data communication network, it is the way